Okay, we're going to have a look at isomers as part of the organic chemistry topic. What we need to do is know what is meant by the term isomer. Here's our definition. Isomers have the same molecular formula, but a different structural arrangement. Let's have a look at some examples to hopefully clarify that. Simplest alkane is methane. It's got 1 carbon, 4 hydrogens. There is only one way of putting those together, so it can't have different structural arrangements. So methane has no isomers. With ethane, here we've got 2 carbons adjacent to each other. You can only put 2 things next to each other. They're above, below, behind, in front. They're still next to each other. So actually, ethane also has no possibility of different structural arrangement. So it's got no isomers. It's only ethane. With propane, we could move this carbon up here to form this. Is this any different to this? And actually, the reality is it's not. It's simply this bond has been bent. So we haven't got a different structural arrangement. So propane actually doesn't have any different structural arrangements apart from this one here. So we find that the first 3 alkanes have no isomers. The first alkane that does have an isomer is this substance here. It's butane, methane, ethane, propane, butane. Let's look at possible different arrangements. Here we've got a carbon. What we've done is we've removed this carbon that was here, this one. We've put it up here. Is that any different? It's a little bit similar to this example here. All we've done actually is bend this. And that's the same as that. So although this is still butane, it's not different to this one up here. So it's not a new isomer. Here is something that again looks very different to this. If you look more carefully, all we've done is we've bent this one up to form this. So although it looks different, actually, if we bend this down again, not breaking any bonds, we're just bending it back again, we make this. So there's no new isomer here. The only way that you can get a different arrangement, a different structural arrangement of atoms for butane is by doing this. And if you look carefully, what we've done is we've taken one of these carbons and we've put it on this carbon. Rather than being on this carbon here, we've taken it, we've put it on this carbon here. Here it is. So this is a different arrangement to this. Here we've got 4 carbons in a row. Here we've got 3 carbons in a row, and a carbon is added onto the middle carbon of those 3. The name of that molecule is butane, C4H10. The name of this is also butane, C4H10. We can be more specific with the name here. And you'll see that it's built upon a 3-carbon structure here. So it's built on a propane structure. And what we've done is we've added a 1-carbon group to my propane. A 1-carbon group is a meth group, a methyl group. So we call it methyl propane. Here's my propane, and here's my methyl group added to the propane. These 2 are isomers of each other. Same molecular formula, C4H10, C4H10, different structural arrangement. Let's have a look at another example. Let's have a look at pentane now. Here's pentane, C5H12. Is this any different? You should remember from the previous slide that all we've done is bent this up. If we bend this down again, we get the same molecule there. So that's not a new isomer. What about this one here? This looks really, really different. If you're careful though, and very perceptive, if you move this one down, and if you move this one up, you end up with 5 carbons in a row, which is the same as this. So although it looks different at first glance, actually it's not a new isomer. What we've got to do is remove a carbon and put it in a different position on my molecule. So here we are. What we've done here is we've removed this carbon here and put it on this carbon here. We've removed the carbon that was here and put it on this carbon here. This has got 5 carbons in a row. This has got 4 carbons in a row and a carbon added on. So it is still pentane, C5H12, but it is different in terms of its arrangement. What about this? Is this any different? We've got 4 carbons in a row, and we've taken the carbon that was here, and rather than putting it on this carbon, as we did here, we've taken this carbon and put it on this carbon here. So this is different to this. But if you're perceptive, if you look around it from the back of the screen, you'll end up seeing the same here. So in fact, although it is still pentane C5H12, it's not different to this one here. So at the moment, we've still got two molecules that are isomers of each other, two versions of pentane, two isomers of pentane. Is there a third isomer of pentane? Is this any different? Again, at first glance, it might do, but if we were to just bend this up, this ends up being the same as this. So that's not a new isomer. Let's have another go. Here, we've got 3 carbons in a row, and 1 carbon has gone up here. This carbon here has now been added to this carbon here to make this structure. This is different to this, is different to this. So we've got our third isomer of pentane, C5H12. If we were to look in a bit more detail and try and name those, you'll see that this molecule here is based on a 4-carbon structure, meth-eth-pro-butane. What we've done to butane is we've got a methyl group, or 1 carbon group, and we've added it to butane. So it's methyl butane, 1 carbon, 4 carbons. And we can be even more specific and say where we've put this methyl group on. It's on carbon number 1, carbon number 2. So methyl group is on carbon number 2 in butane. So we call it 2-methyl butane. Have a think about what we might want to call this. Perhaps pause the video. This is based on meth-eth-propane. So it's based on propane, and we've added a methyl group to propane. We've actually added 2 methyl groups to propane. So we call it dimethylpropane. And if we were to use numbers to say where we've added the methyl groups to, we've added this group, the methyl group, to carbon number 2. We need to say where we've added this methyl group to as well, and that also is added to carbon number 2. So we call it 2,2-dimethylpropane. And we've got 1, 2, 3 isomers for pentane. Let's look at one more example, chloropropane, C3H7Cl. What we've got is propane, but we've replaced one of the hydrogen atoms with a chlorine atom. So this is chloropropane. Here, what we've done is we've moved the chlorine onto this carbon, moved the hydrogen onto that one, and we've made something different. Is this any different? Well, it seems as if we've moved the chlorine atom from carbon number 1 onto carbon number 3, but as before, if you were to look at it from behind, you'd see that this and this are the same. So that's not a new isomer. We've got 2 isomers of chloropropane. They're all C3H7Cl. How do the naming work? Well, the first one is based on a propane structure. And we've got chlorine, so it's chloropropane, on which carbon? Carbon number 1. This one here is very similar. It's based on a propane structure. We've got a chlorine added to it, and the chlorine is on carbon number 2. So it's called 2-chloropropane. This one here, it's worth thinking about, even though it's not a new isomer, because it looks as if it would be called propane, 1, 2, 3 carbons, chloropropane, and it looks as if the chlorine is on carbon number 3. So it looks as if it ought to be called 3-chloropropane, but remember, if we were to view it from behind, we'd count number 1, number 2, number 3. So in fact, we wouldn't call it 3-chloropropane, we'd call it 1-chloropropane, which shows you that that's exactly the same as that. So chloropropane has 2 isomers. You've got some other examples that it's worth working through. Hexane, C6H14. Chlorobutane is worth looking at as an example for investigating isomers. And also, if you feel really challenged, have a go at heptane. What you need to do is get a pen and paper out and work out all the structures of the isomers for those. If you need a hint, I'll share with you now. Hexane has 5 isomers, chlorobutane has 4 isomers, heptane has 9 isomers. Give it a go, see how you get on.